DDS is a technology that comes from the military. It's used in military vehicles, in military ships, in military planes. And this is a perfect fit because DDS is designed for real-time communication between computers and devices connected through a local area network. Its power is when you need a high performance, reliability, scalability, and security. In this video, I will introduce you to a generic vehicle architecture that uses DDS as a communication middleware. Now, a little bit of history. Imagine that there is late 1970s and military vehicles started to become more complex. It's because they became more advanced, with more electronics, with more sensors, with more microprocessors. And in that time, Ministry of Defense started several programs to find out how to systematically integrate all these new technologies into a vehicle. This led to development of vetronics, vehicle electronics systems, vetronics, that are designed for how to integrate all this new equipment into a vehicle. And with the equipment we can think of like communication radios, cameras, fire control systems, crew controls, displays, computers, and so on. And all these equipment needs to be connected together. This equipment needs to share data, and it has to fit into a vehicle. And after almost 30 years of development and such activities, in year 2010, a standard generic vehicle architecture was created. Alright, so what is generic vehicle architecture? GVA is a part of a broader framework called Land Open System Architecture. And what the name suggests, it promotes an open architecture that makes it easier to integrate and operate different systems and without being locked to a specific vendor. So the key principles of Land Open System Architecture are openness, modularity, and scalability. So openness is that we can use a different supplier for an equipment and it will work. Also the modularity, that we can replace or upgrade the equipment and it will still work. And the scalability, that we can add something so the vehicle be more robust and advanced. So we can add, for example, displays or computing capacities and storage, for example. Alright, so these were the key principles of Land Open System Architecture. And GVA aims to make military vehicles creation more effective and with reduced risk in integration of such systems, and also to lower the cost of creation of such system. So this is the main goal of this GVA standard, and this standard describes how to connect everything or connect equipment together, how the equipment should communicate, what is the data model for communication, and for example how to handle alarms and diagnostics in the vehicle. Alright, now we know what the generic vehicle architecture is, but what is a NATO generic vehicle architecture? It's simple because NGVA is an extension of a GVA, but with a broader requirements, for example on unmanned system integration. But the aim is the same, to create a vehicle or military vehicle simpler, faster, cheaper. Alright, so what the NGVA standardize is that it standardizes the overall architecture of the system or architecture approach, power integration, power infrastructure, data infrastructure, terminal crew, software architecture, data model, safety, and verification and validation. All right, so we understand that for creation of the military vehicle, we need the hardware and the software. The vehicle itself, all right, and then the equipment that we put into a vehicle. And this is easy because manufacturers are creating GVA compliant equipment that you can use, and it's like displays, computers, servers, routers, switches, displays. I already said it. So this is the hardware part, and you need the software part, so the applications. And both GVA and NGVA requires to use data distribution service for communication between these applications. And data distribution service as a data bus connects these applications and also promotes the principles of a land open system architecture, which is open, modular, and scalable. Open because DDS is a standard, modular because DDS use publish subscribe communication model, so the data or applications are loosely coupled, and scalable because you can add or remove the applications without affecting the system's function. All right, so this is NGVA. Now let's talk about a little bit data model. Both standards has its own data model, and it's an important part of the standard because this leads to interoperability and as well data centricity. And because we now have single, simple, extensible data model that can be used for communication between all the subsystems in the vehicle, like sensors, effectors, crew terminals, displays. We can stream data, we can process data. So this is important because now we've got that interoperability, that everything will understand what data one subsystem sends to another part of the vehicle. All right, this was information about GVA, which is UK Ministry of Defense standard, and NGVA, which is a NATO standard. But there exist also other standards like Victory, which is standard from US, and Australian Generic Vehicle Architecture. All of these standards uses DDS as a communication middleware that ensures real-time, reliable, scalable, and secure communication between different various subsystems of the military vehicle. So now you know more about GVA, Generic Vehicle Architecture, and how the data distribution service fits into this. And if you are interested more about data distribution service, please visit my website pavelpohanka.cz, where I offer a free sample of ebook called DDS Guide.